Subscribe now.
So now that we understand how the Twiddle factor method came about, of which I explained in my previous video, this matrix that we got is what we call the transformation matrix. Transformation matrix, or the phase matrix, or the Twiddle factor matrix. Yeah. So before we proceed in solving some examples, it should be something common that this should be on your fingertips. But I'm not asking you to memorize. There's some simple way that you can write it. Looking at this structure of the matrix, you can see that the first column is let's say column it's all ones, and then the first row they are also all ones. So that one is easy to remember. So let's start from 2-point DFT. So now I'm showing an easiest way of writing it. So for 2-point DFT, there's nothing to remember. That one is easy. 1 1 1 -1. For a 4-point DFT, that one is something that you must know in your fingertips. This is not the time that you are supposed to draw the complex plane and then do this, and then you do 1 -1 j -j. If you do this, you are going to get it all right, but I think it will waste your time a bit. So what you can do is that when it's 2-point DFT, you use this. When it's 4-point DFT, the Twiddle factor matrix is what you need to do. First of all, just write the ones that you know already. So 1 2 3 4, and here it's 1 2 3. So 1 2 1 2 3 4. Right? This is what you have. Come here, write J, write J, write J, and then write J here. When you are done with the J here, the forward diagonal, they are negatives. And when you do the negatives, what we need to do is the middle here is -1, 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 and the middle here it's what? +1. So looking at this structure, I use less than 20 seconds or even 10 seconds to do that. And looking at this, the same structure that we are having here when we use this part. So this is the easiest way. Write the ones here, do the 4 J's at the 4 corners, attach the negative for the forward DFT, for the forward path, and then the middle of each of the J are all negative, and then the main middle one is a positive. You are done. If it is an ID of t, remember that for the IDFT, the exponential function factor, the negative in front of it goes away, right? The negative in front of it goes away, and that is the complex conjugate. So if we want the complex conjugate, remember that the real numbers do not have a complex conjugate, but the numbers which are not real are the ones that have the complex conjugate. So what you can do is that instead of making the forward J's to be let's say the forward J's to be negative, you reverse it. So it is going to be 1 1 1. Here we go to be 1 1 1, and you write your J as usual, J as usual, J, and then J. So instead of the forward here to be negative, the reverse part will be negative, and then the forward will be positive, and -1, the rest are the same. And then here, so this is the inverse ID, which is ID of t Twiddle factor, that when you are doing the ID of t, you are going to use. So take note of that. So this is the simplest way of writing the Twiddle factor matrix without even thinking of it. So let's move on and solve some example. So example 1. Example 1. So example 1, find the DFT of the following sequence using the Twiddle factor method. Using the Twiddle factor method. So let's write 1 x of n equal to 10 and then 5. Instead of using the Twiddle factor method, instead of using the direct computation, we are using the Twiddle factor method. And for n equal to 2, the Twiddle factor is going to be 1, 1, 1, negative 1. And based on this, as I said, x of k, which is the same as x of 1, x of 0, and then x of 1, should be equal to the Twiddle factor matrix 1, 1, negative, let's say 1, 1, 1, let me write it well, 1, 1, 1, and negative 1, multiplied by the input sequence, which is 10 and what, 5. And based on this, when you do the matrix multiplication, you can use your calculator or you can just use your hand. So 1 times 10 is what, 10, plus 1 here times 5 is what, 5. Get me? That's 5. And then when you come to the down here, we are going to get 1 times 10 is 10, and then negative 1 times 5 is minus 5. So at the end of the day, we are going to get what, 15, and then what, 5, right? 10 plus 5 is 15, and then 5, and therefore we can see that our x of k is equal to 15 and what, 5. So as you can see, this is the easiest way of solving for the DFT instead of using the direct computation. So looking at things here, you can use the previous example to try your hands on by using the the Twiddle factor method for 2-point DFT. The examples that I gave it to you in my previous videos, you can use this method to do them as a practice. So let's move at the case whereby n equal to what, 4. So the case whereby n equal to 4, I showed you how to write a Twiddle factor without even thinking of it. So the Twiddle factor matrix is going to be, as usual, 1, 1, 1, 1, and then 1, 1, 1. So j, 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 j. Since it's a forward DFT, we bring the negatives at the forward, and then the middles are the negative ones, and then this one is 1, and then now you are done. You don't have to think of it. You have your Twiddle factor matrix here, and then for giving the sequence x of n equal to maybe 1, 2, 3, and 4, you are going to get x of k, which is equal to x of 0, x of 1, x of 2, x of 3. And then based on this is equal to the Twiddle factor, which is what, 1, 1, 1, 1, 1, 1, 1, j, negative here, j, 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 and here negative, negative 1, negative 1, negative 1, negative 1, and then 1. And then the input are 1, 2, 3, 4. So based on this, you can either use your calculator or do normal computation, and you are going to get something like 1 plus 2 plus 3 plus 4, and then 1 minus 2j minus 3 plus 4j, right? You are doing row and column multiplication, and then you are going to get 1 minus 2 plus 3 minus 4, and then last one is 1 plus 2j minus 3 minus 4j. So when you do the calculation, you are supposed to get something like, when you can, yes, 1 plus 2 3 plus 3 and then 10 give you, and this one 4j minus 2j get it 2j, right? And then the rest also multiply, we are going to get negative 2 plus 2j, and then the next one we are going to get a negative 2. And remember that, as I told you, when you are finding the d of t, when after removing the first element, when you find the second element, you find the third element, the other part is a complex conjugate, so you can just look at it and say negative 2 minus 2j, right? Exactly. Or when you have done with this, you can just put it there. So now this is your x of k in the frequency domain, which is n negative 2 plus 2j, negative 2 minus 2j. So this is our final answer. So as you can see, the Twiddle factor method is very, very, very easy to do. So to practice more questions, please go to my previous tutorial, pick those questions that we use direct computation to solve them, and use the Twiddle factor matrix method to solve them, right? So that is that's for the linear transformation matrix. In my next tutorial, we are going to talk about how to do the inverse DFT using the linear transformation method, which is the Twiddle factor method. So thank you for watching, and see you in my next tutorial.